Have you ever wondered how the Moon, a dry and airless world, manages to have its own atmosphere? Well, the answer lies in a fascinating process called space weathering. And in this video, we're going to explore the surprising origins of the lunar atmosphere. The lunar surface may seem barren and lifeless, but just above it lies a thin layer of atoms and molecules known as the lunar exosphere. This tenuous atmosphere was first observed by scientists in the 1980s, and it has since been studied in detail by missions like LADEE. So, how does a world without an atmosphere end up with one? Let's dive in and find out. The lunar exosphere is a unique feature of our Moon. It's not a dense, breathable atmosphere like the one we have on Earth, but rather a very thin layer of atoms and molecules that cling to the lunar surface. These atoms, including potassium and rubidium, are constantly being kicked up and suspended in the exosphere by the impacts of tiny meteoroids and micrometeoroids. It's a never-ending process that helps maintain the delicate balance of this lunar atmosphere. The Moon is constantly being bombarded by these small objects, and that bombardment is actually a major driver of the lunar exosphere. As these tiny particles impact the surface, they can vaporize some of the material, releasing atoms into the thin atmosphere above. So the lunar exosphere is not a static or stable feature, but rather a dynamic and constantly replenished layer of material. This raises an intriguing question. What is the primary process responsible for creating and sustaining this atmosphere? To answer that question, a team of scientists from MIT and the University of Chicago set out to investigate the origins of the lunar exosphere. Their research, recently published, has provided a definitive answer. We've determined that impact vaporization is the dominant process that creates the lunar atmosphere. The Moon has been continuously bombarded by meteorites for billions of years, and this constant bombardment is what's responsible for vaporizing material from the surface and releasing atoms into the exosphere. The scientists analyzed samples of lunar soil collected during the Apollo missions, focusing on the levels of potassium and rubidium. These elements are particularly interesting because they vaporize easily, and the ratio of their lighter and heavier isotopes can provide clues about the processes that have shaped the exosphere. By looking at the isotopic ratios in the lunar soil, we were able to prove that impact vaporization is the primary driver of the lunar exosphere. The specific patterns we observed in the soil samples clearly point to impact-related vaporization as the dominant process. So the constant rain of tiny meteorites onto the lunar surface is the main culprit behind the formation of the Moon's atmosphere. But there's another important factor at play as well. In addition to impact vaporization, the solar wind also plays a significant role in shaping the lunar exosphere. The solar wind, which is a stream of charged particles emanating from the sun, interacts with the lunar surface and can also sputter off neutral atoms. This process, known as ion sputtering, contributes about 30% to the creation of the lunar exosphere. So while impact vaporization is the dominant process, accounting for around 70% of the exosphere, the solar wind's influence is also an important factor in the overall picture. The delicate balance between these two space weathering processes helps to continuously replenish the lunar atmosphere, keeping it in a steady state, despite the constant loss of atoms to space. Understanding the origins and dynamics of the lunar exosphere is not just an academic exercise. It has important implications for future lunar exploration and habitation. The constant bombardment of the lunar surface by meteorites, as well as the ongoing effects of the solar wind, pose significant risks to any infrastructure or human presence on the Moon. These space weathering processes can erode and degrade materials, posing challenges for the design and construction of lunar bases and other facilities. Additionally, the lunar exosphere itself could present some unique challenges for future lunar explorers. While it's not dense enough to provide any kind of breathable atmosphere, the atoms and molecules in the exosphere could potentially interfere with scientific instruments or other equipment. Understanding the origins and behavior of the lunar exosphere is crucial for developing effective strategies to mitigate these risks and ensure the success of long-term lunar missions. By studying the space weathering processes that shape the moon's atmosphere, we can better prepare for the challenges of living and working on the lunar surface. The moon's atmosphere may be a surprising and unexpected feature, but its origins are now better understood thanks to the groundbreaking research we've explored today, from the dominant role of impact, vaporization to the influence of the solar wind. The lunar exosphere is a complex and dynamic phenomenon that holds important lessons for the future of lunar exploration. As we continue to push the boundaries of human presence on the moon, understanding the secrets of its atmosphere will be crucial for ensuring the safety and success of our endeavors. So keep an eye on the skies and the lunar surface. There's still much more to discover about our closest celestial neighbor. Thanks for joining us on this journey of lunar discovery. If you enjoyed this video, be sure to subscribe and stay tuned for more exciting updates from the world of space exploration.